In this video, I'm going to go over some basic examples of curve sketching, particularly for polynomial functions. But there's four fundamental shapes that you need to be familiar with. So this is the first one, this is the second, here's the third, and this one is the fourth. So let's talk about the second derivative. This is a concave down shape, and whenever you have a shape that's concave down, the second derivative is negative. So for the two shapes on top, because they form a downward U shape, the second derivative is negative. For the two shapes on the bottom, they form a concave upward shape, so the second derivative is positive. Now for the first derivative, if the graph is going up, the first derivative is positive. If it goes down, it's negative. So here we have an increasing function, it's positive. This one is going down, so the first derivative is going to be negative. Here we have another decreasing function, is going down, so it has a negative first derivative. And this one's an increasing function, is going up, so the first derivative is positive. Now, the reason why you need to know this is that when you create a sign chart for the first and second derivative, you can get a good idea of how the graph is going to look like, at least the curve. And I'm going to give you two examples to illustrate that. So let's plot this particular polynomial. Let's say that f of x is equal to x cubed plus 6x squared plus 9x. Go ahead and graph it. Now the first thing I'm going to do is find the x-intercepts. So I'm going to factor out the GCF, which is x. And I'll be left over with x squared plus 6x plus 9. So that's a perfect square trinomial. Two numbers that multiply to 9 but add to 6 is 3 and 3. 3 times 3 is 9, 3 plus 3 is 6. So it's x plus 3 times x plus 3, which we can write as x times x plus 3 squared. So if we set the function equal to 0, we can see that the x-intercepts are 0 and negative 3. So I'm going to put those points in a data table. So we have the point 0, 0 and negative 3, 0. Now let's find the first derivative of the function. It's going to be 3x squared plus 12x plus 9. Now let's take out the GCF, which is basically 3. So we're left with x squared plus 4x plus 3. And then we could factor the trinomial. Two numbers that multiply to 3 but add to 4 are 1 and 3. So we can write it as x plus 3 times x plus 1. And if we set the first derivative equal to 0, we can get the critical points negative 3 and negative 1. So we can plot this on a number line. And it's good to put the critical points here. We already have one of them, so the other one we're going to put is negative 1. Now let's create a sign chart. So if we plug in a number that's greater than negative 1, let's say 0. 0 plus 1 is positive, 0 plus 3 is positive. So the first derivative is positive in this region. If we plug in negative 2 plus 3 is positive, negative 2 plus 1 is negative. So the function is decreasing between negative 3 and 1. And if we plug in negative 4 plus 3 is negative, negative 4 plus 1 is negative. Two negatives make a positive. Now that's for the first derivative. Let's create a sign chart for the second derivative. Also, notice that we have a maximum at negative 3 and a minimum at negative 1. So at negative 3, notice that to the left the function is increasing and then to the right is decreasing. So that's a max. For the negative 1 critical point, it's decreasing then increasing. So that's a minimum. So I'm just going to mark that here. So at negative 1 we have a minimum, and at negative 3 we have a maximum. Now for the second derivative, it's going to be 6x plus 12. So if we set it equal to 0 and take out 6, we can see that a potential inflection point could be -2. So we need to create a sign chart at -2. So if I plug in 0, 0 plus 2 is going to be positive. And if I plug in something less than -2, like -3, -3 plus 2 will be negative. So that tells us the concavity of the graph. So what I need to do is combine the two sign charts. So we're going to have the points -3, -2, and -1. So on top, I'm going to put the sign for the first derivative, and on the bottom for the second. So the first derivative is positive to the left of -3. And between -3 and -1, it's a negative. And to the right of -1, it's going to be positive. So we can get rid of this at this point. And keep in mind that we have a max at -3 and a minimum at -1. Now for the second derivative. It's negative to the left of -2, and then it's positive to the right of -2. So now, let's draw the shapes that we have for these 4 sections. So what type of shape do we have if the first derivative is positive and if the second derivative is negative? So let's start with the second derivative. If it's negative, it's concave down. And the first half is the part that's increasing where the first derivative is positive. So we need to draw this shape. So it's going to look like this. Let me use different colors. So I'm going to make this one red. Now for the second part, the first and second derivative are both negative. So it's concave down, and we need the second part because the function is decreasing. So we need this part. Now here the first derivative is negative, but the second is positive. When the second is positive, it's concave up, but if the first is negative, it has to be decreasing. So we need that portion. And then for the last one, it's concave up and the function is increasing. So here's our concave up shape, and this is the part where the function is increasing. So let's combine these 4 fragments into one graph. So it's going up, and then the blue part, it's going down, and then the green part, it goes down and then it turns, and then the white part, it goes up. Now this is in line with the maximum that we do see at -3 and the minimum that we see at -1. So now we know the general shape of our graph. And it makes sense because x cubed, the parent function, looks like this. It's decreasing on the left, increasing on the right. So all we need to do is combine this shape with this data table. So let me get rid of this structure. Now let's draw a graph. Now we need to find the y values for those 2 points. So when x is -1, it's going to be -1 to the third plus 6 times -1 squared plus 9 times -1. So that's -1 plus 6 minus 9. So negative 1 plus 6 is 5. 5 minus 9 is negative 4. Now let's do the same when x is negative 2. So negative 2 to the third power, that's negative 8. Negative 2 squared is 4 times 6, that's 24. And 9 times negative 2 is negative 18. 24 minus 18 is 6. Negative 8 plus 6 is negative 2. So now let's graph it. So the first point that we have is negative 3, 0. That's the first x-intercept, and we have another x-intercept at 0, 0. And then we have a point negative 1, negative 4, and then negative 2, negative 2. Now, negative 3, 0, that's a maximum. So I'm going to draw the graph in red. So we should have some type of structure that looks like that. And at negative 1, we have a minimum. And following this graph, we know it's going to look something like this. Let me see if I can do that. Make it better. Maybe not, but you get the picture. So that's the general shape of the graph that we had. Let's work on one more example. So let's say that y is 3x to the fourth plus 4x cubed. Go ahead and graph this function. So first, I'm going to look for the x-intercepts. So I'm going to factor out x cubed, and I'm going to have 3x plus 4. So if I set this equal to 0, I can see that x is equal to 0. And if you set 3x plus 4 equal to 0, x would be negative 4 over 3. So I'm going to put that into the data table. So we have negative 4 thirds, comma 0, and 0, 0. So now let's move on to the first derivative. And that's going to be 12x cubed plus 12x squared. So if we take out the GCF, which is 12x squared, we're left with x plus 1. So the critical numbers are 0 and negative 1. We have 0, but negative 1 is a new one that we can add. Let's go ahead and get the y value for that. So that's going to be 3 times negative 1 to the fourth power plus 4 times negative 1 to the third. So that's going to be 3 minus 4, which is negative 1. Now let's plot the critical numbers on a number line. So if we plug in, let's say, 1, 1 plus 1 is positive, 1 squared times 12 is positive. If we try negative 1 half, this is squared, so that's going to be positive. Negative half plus 1 is also positive. If we try negative 2, this will always be positive because of the square. Negative 2 plus 1 is negative, so this is going to be negative. So notice that it's decreasing and increasing, so we have a minimum at negative 1. Now, the sign doesn't change across 0, so we don't have a minimum or maximum. So I'm going to write this. We have a minimum at x equals negative 1. Now let's find a second derivative. So that's going to be 36x squared plus 24x. So let's set it equal to 0, and let's take out 12x. So we're going to have 3x plus 2. So the points of interest are, this will give us 0, and this will give us negative 2 thirds, which I need to write that in here. I already have 0. Now if I plug in 1, 12 times 1 is positive, 3 times 1 plus 2 is positive. If I plug in negative a half, 12 times negative 0.5 is negative, 3 times negative a half, that's negative 1.5 plus 2, that's positive. A negative and a positive will give me a negative result. And if I plug in negative 1, 3 times negative 1 plus 2 is negative. 12 times negative 1 is negative. 2 negatives make a positive. So now I need to combine this into a single chart. But before I do that, let's find a y value when x is negative 2/3. So that's 3 times negative 2 over 3 raised to the 4th power plus 4 times negative 2 over 3 raised to the 3rd power. So negative 2 to the 4th power is 16. 3 to the 4th is 81. And 3 divided by 81, that's going to be like 1 over 27. Negative 2 to the 3rd is negative 8 times 4. That's going to be negative 32. And then 3 to the 3rd is 27. 16 minus 32 is negative 16. So this is going to be negative 16 over 27, which is a little bit lower than negative a half. So now we can combine the two sign charts. So the lowest point is negative 1, and then it's negative 2/3, and then 0. So we're going to put the first derivative on top and the second on the bottom. So the first derivative is negative to the left of negative 1, and it's positive everywhere else. So to the right of negative 1 is going to be positive. Now for the second derivative, to the left of negative 2/3, it's positive. Between negative 2/3 and 0, it's going to be negative. And then it's positive to the right of 0. Now go ahead and identify the fundamental shapes that correspond to this sign chart. So when the second derivative is positive, we know it's concave up. And the first derivative is negative, so that's going to be the decreasing part of that curve. So it's going to be going like this. And then for the second part, it's still concave up, but this is the increasing part of that curve. And so we can see why it's a minimum at negative 1. You could see the minimum here. Now, this one is concave down, but it's increasing, so we have the right side of it. Actually, I drew the concave up graph. This is supposed to be concave down. And so this is the increasing portion of it, which is this side. So we have this particular shape. And then this is concave up again, which is like this. And we have the increasing portion of the concave up curve. And let me put that in white. So combining these four fragments, we're going to have a graph that looks like this. So that's the shape of our graph. So this is going to be negative 1 because we have a minimum at negative 1. The next point of interest is negative 2/3. And then at 0, we have a horizontal tangent. And then that's it. So now we just got to take that curve and put it in to an actual graph with the right points. So just keep that shape in mind. Now let's make the graph. So we don't need too many points. So we're just going to get up to 2 on each side. So the first point is at negative 4/3, which is about negative 1.33. comma 0. So that's an x-intercept. The other x-intercept is at the origin, 0, 0. And then we have the point -1, -1, and then -2/3, which is like -0.67, and -16/27, which is somewhere below -0.5. So we could say about here. So those are the 4 points. They're pretty close to each other. Now, -1 is the minimum, so we're going to have this type of shape. Well, let's draw the 4 shapes that we had. The first one was like this, if I remember correctly. And then the second one was like that. And then the third one continued and then went that way. And then the fourth one it kept increasing. And the first one, if you just extend it, it's going to increase as well. And so that's it. That is the graph that we should have. And so we can see the minimum at -1. And that's all I got for this problem. So hopefully this gave you a good idea of how you can use the first and second derivative to help you draw a rough sketch of a polynomial function. Now I have another video on curve sketching that has more examples. It's an older video, so you can check that out, but it still covers the same principles that this video covers. It's just a longer video with more examples if you still want to get more practice with this type of topic. So thanks again for watching.